Hey guys, welcome to the stream. I guess there may be some reverb issues, so I'll turn that off. I hope so you can listen to my voice as well as the music in the background. So today again we will solve 3 questions that were asked in the famous companies, the big tech companies, and I will be referring to Kunal Kushwaha's 5 hours long video where he has taught us that how to solve the questions. I will try it myself first, and then if I cannot solve it, I will take reference from his video. So let's start. Alright, I'm going to go here. So he's an amazing guy. Check him out. I've learned the entire DSA from him, almost the entire DSA. And I guess once he teaches you the concept, you don't have anything much left to do otherwise rather than practicing. So it helped me a lot. Maybe you may prefer some other guy, but my preference is this.
Using Q, so it's going to remain O of n only. Till the time you're using this extra Q, it's going to remain.
Okay. So
In O of n.
Sometimes when you take screenshots of videos, like once you pause the video and you want to take a screenshot, then these things come up, right? And sometimes like these things are invisible to you when you take a screenshot of something that you're learning from YouTube. So for that you can use one extension called HYDE, one Chrome extension which can also run on Edge, which will hide these bars from you so that you can take a screenshot of the video. So that's all. So we were doing BFS in binary trees. Okay. Let me see what was the thing about. So we had, let us open the VS Code. We have a tree, and in breadth first search, what do? We go level by level in a tree. And when do we use it? We use it when the answer is near the root node, because we know in binary tree the root node, the height of the tree is log n of the is approximately varies log n, where n is the number of nodes present in the binary tree. Okay, so when the answer we believe is nearer to the root node, then we use level order traversal or binary or BFS, breadth first search. Okay, and when we are asked to find some queries level by level. Okay, so here we have written a code because in platforms like LeetCode you are given test case, but here no test case are given. So we have written our own binary tree, okay, where we have a nested class node that has a value section, a left and a right section. The left will and the left and right pointers will point to a similar node like itself. Okay, and we have a function called populate the tree, which calls another private function populate key. In Python, in Python there are no private functions. Okay, by convention, if you have two dash before a function, it tells the other programmer that you're collaborating with that this is a private function, so you cannot call it outside the class. But even if you do it, it will show even if you call it outside the class, it will work, but it will show some error warning. Okay, if you turn on the linting over here in the setting, type check, I guess. Here, if you turn on the basic standard strict type checking for Python, then it will show you errors and bunch of problems like that. See, once I have turned on strict, it is showing me warning over here. Here is a warning. See all the red dots over here. These are all the warnings. But I have run my code. I know that it is working according to what I want, right? But this is showing that if it was a strictly type checked language, then what you should do and what it thinks that it should happen. Okay, so you can go for basic one, but I prefer off because I can modify and I get yellow warnings are better than getting red warnings. Less annoying, in my opinion. Okay, so this warning is showing because it is saying that I am redefining the array, which I am not, because this array reference variable is different from this array reference variable, but the smart analyzer does not know that. It is thinking that I am modifying this array everywhere. Okay, that is why it is showing an error over here, but not a problem. So populate the tree, where we take one array and we populate the tree. A pretty print function where we print whatever node is there in a visual manner, so that we can visualize the tree in front of our eyes. Okay, and BFS, where we traverse level by level order, level by level in that tree. Okay, so let me revise it a little, okay, for my own reference. So suppose we have 7 items, 1 2 3 4 5 6 7 items over here. Okay, so this creates a binary tree object. Initially the binary tree does not have any node, but when we say populate the binary tree according to the array, it will try to create a balanced binary tree according to the array. Okay, so let us see what tree it has created. So you can see over here that, 1 second, why 7 is not showing? Now it is showing. Yeah, you can see it has created a binary tree with 4 as its root node, and the left child has 2, the right child has 6, and these are the leaf nodes. Okay, it is a perfectly balanced binary tree where all the levels are filled and every node has 2 children. Okay, this might not be the ideal case situation, but I have taken this according to my preference. So BFS, so let me write the BFS code for my own reference once again. So once again, am I live? Can I watch? Okay, I can watch it. worries. So I'll write the function once again for my own practice. Okay, so I will turn on the music so that you don't. Alright. So I guess in this way you are not getting bored as well. Hello. Yeah. Everything is fine. If we write the PFS code once again. I'm revising the things that I've already learned. I'm saying because I forgot, I guess. So the main problem of PFS is once we go to the child node, okay, from the parent node to print level wise, then how can I have the information about the right sibling that I have, okay, here. So we cannot to find the value of the right sibling, we have to again fuck it. Yeah, one more difference. अबे यार पेन कहाँ चला गया? Have one more thing. Okay, so if we are in this node, okay, so we before printing the other this node, we have to store the value of this and this, so that we have to store the value of 4 and 12 so that in the future we can traverse accordingly. So after 20, 8 should come. Okay, so we will print 20 and then we will store the value of 8 and 22 in a queue accordingly. Okay, and then we will come here. Let us see this example. This is the better. Let me see. So we have to first go to 8 here, then 8 will come here, 8 here, we have to print 8, and before popping 8 out, we have to store the next should come 4 and 12. So 4 and 12 are the children of 8. So we will store 4 first, then 12 second in the queue or in the array or in the list, you may say. It is a queue because first in first out is being applied. Okay, first in and first out. 8 was inserted first and it was deleted first, so that is why we are saying it is a queue. So 8 was inserted first, okay, then we print 8, and after printing it, the work of 8 is finished, so we now have to pop 8 out. But the next node that we want to go to in breadth first search or level or traversal are the two children of 8. Okay, so how can we so once the work of 8 is finished, and if we go to 4, then how can we get to 12 without going back to 8 again, right? So we have to store the value of we have to store the node 12 in our list, with the help of which we can traverse there. Okay, so 4 is stored here, so now we have to print 4. So 4 is printed, 8 is printed, 8 is printed, 8 is popped. Okay, so 4 is traversed and 4 is operation is print. Let's say 4 is printed, 4 is popped, and before it is popped, the children of 2 and 6 is saved in the queue after 12. You see that the way we want to traverse, first 8, then 12, then 2, 6, 10, 14, that in that order the queue is saving the upcoming nodes. Alright, it may make sense if you have done BFS before. If you have not, then watch the videos on YouTube. It may be efficient. Okay, so yeah, so what will be in the edge case? The edge case will be the queue will be empty. So when 15 we reach 15, we will print 15, and after printing 15, 15 does not have any children, it has null. Okay, null. So because null, we are not pushing it into the queue, so ultimately the queue will become empty, and we will pop 15 from here. We will pop 15 from here, and the queue will become empty. And when the queue becomes empty, then we don't do anything. Okay. So this is how we will implement BFS in code, in theory. So let us implement this in code. So we will make one function, BFS traversal. We have to put self, because a method is inside the binary tree function, binary tree class. So that is why in Python we have to mention self over here, where it will self means it is using an object of the class binary tree. So the self is telling you that, basically it is telling you that when we call the method BFS, it is automatically working. It will be automatically working upon an object which is of the type binary tree, which is the method is a part of. Okay, so if you see that, this also makes sense, because in order to use these methods in order successors or print, you have to create an object first, right? So you have created an object first to use that. So in print, you see, in print you are not taking any parameters over here. Okay, but automatically this binary tree object is passed in the parameter of the print. So that it can perform an operation onto that. Alright, so BFS is there. So we will say that if self dot root is none, which cannot be the case. Can it be the case? Yeah, it can be a case because we have made a tree. The tree is being initialized only when we are calling the method populate tree in our case. Okay, so we won't do anything. We will return none. Okay, and if it is not none, then what do we need to do? We will make a queue. The queue will be, initially it only has the first item, self.root. Okay, so we have to say that while the queue is not empty, I don't want suggestions. I will turn on the Copilot now. Copilot disabled. Okay. Beta. So we can see here that if the queue is empty, then nothing is happening. Okay, if the root is empty, then nothing will happen. The root is not empty. Initially, let me say the answer is an empty one. Okay, the answer is an empty list. So there is one queue. Initially, the root of the queue has the root value as its first node, as its first entry. So now we have to store the value. So now we have to store the value of the root level by level inside the answer list. Okay, so the answer will be a 2D list, 2-dimensional list. Okay, so since the queue has, and we will run it while the queue is not empty. Okay, so while queue is also mean the while queue is not none. Okay, so this thing you can in short write like this as well. This will also work. While queue is not none, then what do you need to do? While queue is not none, you have to traverse level by level, this level, like that. Okay, so for that, what are we doing? So we will say level will be equals to length of the queue. Okay, so alright, the length of level will be equals to length of the queue, and then what we need to do, then we have to pass the value of it in the we will make one temp array over here, temp list over here. Okay, so now we have to traverse for I in range level, or should we say this as n? level we have written over here. So we don't need the index. Do we need the index? As far as I remember, we don't need the index, but if we need, then we can change it back, this thing with an I. Okay, so we'll traverse level by level. Alright, so because as of now the queue has only one item, so n will be equals to 1, so the loop will run one time only. So now what we need to do, we have to say that maybe I is required. We have to say that no, not required. We have to say that pop the first item. Item will be equals to queue dot pop the 0th index. Okay, we are popping the first item, and then what? We are popping the first item, and we are inserting the value. Level.append item.value. Okay, so after popping the first item from the queue, we have stored it in a variable called item. So item will be of the type node. Okay, and there we are appending the value of the item here. It will be of the type value. Now what do we need to do? We have to check, we have to insert the left and right we have to insert the children of the item, the current item. Current sounds more appropriate. If current is not null, current dot left is not null, we have to insert it into the queue dot append current dot left. If current dot right is not null, then we have to append queue dot append current dot right. Right, okay, so yeah, we did not have to get the index here in the for loop. And after that, after the for loop, we will insert the level that we have got into the answer list dot append level over here. Okay, and then when the while loops have ended execution, we are returning the answer. Okay, sounds good, seems good. Yeah, okay, I will copy the logic over here. Copy the logic. Let us see if it runs over here. It may get some problem. I don't know. Let's see. It is seeing some problem is there in Python. Where have I used level like that? Seriously, have I used level here? This autopilot thing, na? Sometimes it is so frustrating. Okay. This is returning a value. So I have to print the returned value. Guess 4261357. Yeah, it is working fine. Let us see whether it passes all the test cases on LeetCode. LeetCode. What is the question number? Let's see from Kunal's video. LeetCode 102. LeetCode 102. Oh, I've already solved the question as far as I remember. Let us do once again. It should work. Let us see the code. Answer is not root. Q is root. While Q, yeah, we did the same thing. We have taken a temp array over here. For this thing is also same. Insert the value of the children. If the current item in the queue. Okay. Done now. Everything is fine. Has also worked. I have to learn how to implement deck, which is a built-in function for built-in class for implementing stacks and queues in Python. As of now, I'm using list methods only. So deck is much more efficient. So if you see when I submit the code, the logic is fine, but it still does not beat 100%. Yeah, here it is not beating 100%. And if you see the code of these users, yeah, these users have used the queue, the deck object over here. So I don't know how to implement that. I have to learn this. Learn that. Alright, no worries. Let's see the average. Similar questions over here. This one I guess I have also implemented. Given the root of the binary tree, return the bottom up level order traversal of its nodes values from left to right, level by level, from leaf to node. So it is saying us to do the reverse of the thing. Okay. It is saying us to do the reverse of what we did, so we can just reverse the entire thing, that is how I have implemented that. Yeah, or you can just insert it in the front rather than inserting in the back. You can insert it in the front. Okay, same thing, like 3, 9, 20, null, okay, null, 15 and 7, so it should return 15, 7, 9, 20 and 3. So first you will go to 3 and you will insert 3 into the queue, then you will append 3 into the answer list. Okay, you will append 3 into the answer list, and after that you will see that whether the left and right children are null. So in this case it is not, so it has left child, so you will insert the left child into the queue. Okay, and after that you will insert the right child also into the queue, and then you will pop the 3 from the queue. Okay, you will pop the A from the queue, and then again you will do the same thing for 9, 20, 15 and 7 as well. But the only difference is, in this case you are rather than appending it into the last of the list, you are inserting it in the first. Okay, simple logic here. This was asked by Amazon. Here also it is beating 81.81%, but memory it is not that efficient because we are not using DEC over here. If we used DEC, then it would have been more efficient. So it was the third question. Average of level order. That too, you know, it is easy. Level order successor of the node. Yeah, this question I want to solve again. That successor in BST, predecessor of BST. So this question I thought was easy, but this was not. In BST. Okay. I thought this was easy. It was a very easy question. And I have to log in. Study. Once again, it felt like I cheated a bit. No worries. So I thought, what kind of question is this? It was asked by Microsoft and Amazon, right? Company tax. Oh, company tax. Morgan Stanley asked it, Amazon asked it, Microsoft asked it. I was like, what kind of question is this? Which they are asking. Which I was wrong, because they have made a constraint that the time complexity cannot exceed the height of the binary tree, and the main problem was the auxiliary space cannot exceed 1. Okay, so you cannot have an auxiliary queue or stack, which we saw in the last question, right? So for that, so in order to tackle that, we have to use some logic over here. So the logic says over here that if you want to find the successor, right? You want to find the successor of a node. For example, you want to find the successor of the node 12 over here. Okay. So, and currently you are in 20th node, and in binary search tree you know that if 12 is less than, and you have to find a successor. So the successor of 12 here is 14 over here. Here the successor of 8 is 12, the successor of 20 is 22, and the successor of 22 is null because it does not have anything in its right. So the main problem that I face, that you will face, that suppose you have a binary tree like this. Problem. Let me switch it here. Okay. So the successor question asks us to, the problem with this question is, suppose you have a success, suppose you have a tree like this. Okay. 10, 22, 4, 12 and 10. Let us say we don't have 14 like this tree over here. So the problem is, so the first logic I did that I applied is find the node itself, and then find the right value of this node. Okay, but the problem was that this 12 does not have anything right of it. It does not have any right subtree. So when we do in order traversal, the successor of 12 should be 20, because 20 is just because 20, we know in order traversal the tree moves, the BST returns a sorted list. Like here the BST will return 4, then greater than 4 is 8, then 10, then 12, then 20, then 22. Alright, so the successor of 12 is 20. So then how can you find this 20? Once you reach 12, then how can you know that you have to recurse 2 steps behind to find this? And how can you know that you cannot find a successor, you cannot find a value which is smaller than 20, right? If 20 was below that, you could have found it easily, but 20 is not below that, 20 is above that. So in that case you cannot find it. So somehow once you have to store the value in a successor node in a variable. If you have to save the 20, save immediate answer in a variable before checking below nodes, below subtrees. Okay, so let us observe a thing over here, that we will enter the tree via this node. Okay, so is 20 greater than the key value? Let us suppose is 12. Is 20 greater than 12? And I will say yes, 20 is greater than 12. So 20 may be a possible answer, right? So 20 is a possible answer because 20 is greater than 12, and anything right of 20 is not of any use of us, because anything right of 20 will be inevitably greater than 20, because we are in a binary search tree. Okay, so by definition of that, anything greater than 20 will lie on right of the subtree, right of the tree. Okay, so then we will check that can we find anything which is greater than 12 but which is less than 20. So we will go towards left. So when we go towards left, we are seeing that is 8 greater than 12? We are saying no, it is not greater than 12. So it is not of any use of us. And because we know that anything left of 8 will be also less than 8, so this entire subtree is of no use for us. So we will go here, go to 12, and we will check further. Okay, so we have come to 12, And in 12 we are seeing that, hey, are you greater than 12? In 12 we say, no, I'm not greater than 12, I'm equals to 12. So when it says that yes, it is equals to 12, then it is inevitable that we have found the answer. Okay, we have found the key, and once we found the key, then we don't need to check any further. Or do we need to check any further? Yeah, we have to check further for the right subtrees. No, it may exist, we don't know it yet. It may exist. Suppose it has a right subtree called 14, like over here, right? So when we reached over here 12, it is saying, hey, are you greater than 12? So we say, no, I'm not greater than 12. And because we are trying to find a successor, we are not trying to find the key node over here. So we can infer that this subtree, which is equals to greater than 12, is of no use to us. So इसे ये कोई काम करने इसको भगा दो. So we will come over here in 14, and in 14 we are saying, hey, are you greater than 12? And it is saying, yes, I am greater than 12. So inevitably, because we have come towards left from the parent node, then 14 should also be less than 20. So inevitably, in terms of logic, we can say that 14 is greater than 12 and less than 20. Okay, so we will store the value 14 as the immediate answer, and then we will check forward. Okay, until we find when should we stop checking. Until the root node is none, right? Because if the 14 does not have anything, so once we find 14, anything greater is of no use to us. So we will check left, and if left subtree, and if the left subtree is null, then we have reached the end. Alright, so this thing is of no use to us. So we will go over here, we will go left. So this was the concept. At first it seemed really easy, but it was not. So that is why I guess it was asked by Amazon and Microsoft. Let us code it first. So the first mistake that I made is by not reading the question properly, and it is saying a given BST and the reference to a node X in the BST. Find the inordered successor of the given node in the BST. So okay. So my task is you don't need to read input or print anything. And a reference to a node X in the BST. So X is a node. It is also not mentioned over here, but if you come to Java, you can see that X is also a node. So this thing also you can do if you are not comfortable. Because I have made a mistake that I thought X was a value as an integer, not a node. That problem I also faced. So if you also face same problem like this, you can change the language, statically type check language, and you can see that what value that they have given. So here root is also type of node and X is also of type node. So I've come here to the Python because I'm more comfortable in Python. I also know Java. I'm also comfortable in Java, but I see future of me doing more Python. So why not get better at that by practicing it more? You don't need to read input or print anything. Your task is to complete the function inorder successor. This function takes a root node and the reference node as arguments and returns the node in, you see, root node and reference node. Yeah, this thing I missed. when I solve the problem for the first time. Okay, and that is in order successor to the reference node. If there is no successor, return none value. So let us start there. So we will start by checking if root is not none, and x is not none. If root is none and x is none, then we don't do anything, return none value. Okay, so now if root is none, if root is not none, then what should we do? If root is not none, then what should we do? Then we have to say that we have to first save the root value in a node, right? While node is equals to root initially, and the successor will be equals to none initially. Okay, so we have to say while node is not none, then we have to say that we have to check whether this node is greater than the key value. Okay, so let me save the key value in a separate variable like this. Alright, so x dot value, no, x dot data is there, if node dot data is less than or is greater than the key value, then it may be a potential answer. Then successor will be equals to node dot data. Okay, and anything right of it is of no use to us because it will be greater than the current successor. So we have to go towards left. So then we will check node will be equals to node dot left. We will check the left subtree, and else if node dot data is greater than not greater than key, if it is less than or equals to the key, then this entire subtree does not contain our answer. So we need to go towards left to find our potential answer. Okay, so node will be equals to node dot right. So after this happens, we will return the successor to the calling function to see whether it works or not. Runtime error is there. Int object does not have any attribute data. Why? Is it saying that? Do we have to return the node or do we have to return? We have to return the node, I guess. That is why it is showing an error. Return the node. Okay. There is a type node. Now it should work, I guess. Yeah, it is working. Let me submit. It took me a lot of time to do it for the first time, yaar. I'll be honest. Okay, problem solved successfully. So similar way we can find the predecessor as well of binary search tree. So yeah, that's all. Let us come over here.
Moving
and
forward, now the
see-
next question again asked at Google.
So it was asked for Google level order successor of a node.
Very simple.
It is asking us to find out the level order successor of a node, which is quite simple. If you see that I tried to find it on LeetCode. But I could not find it. So for that reason, I have to write it on my own system. Okay. So def level order successor. We will take an object or reference, an instance. Yeah, we'll take one instance of an object. As you can see, yeah, we'll take one instance of an object. I forgot to. Oh no, I forgot to change it. Yeah. Binary tree questions for Google and Facebook, Amazon, Microsoft. Okay, so in this scenario, you can see that what are we doing? Scenario, we have to find the level order successor. So the value, the key value will be given, and then we have to find the level order successor. I'm saying pass. Okay, so now let us see what we need to do. Suppose we have a node, we have a tree like here. Let me switch here. Okay, we are doing level order successor like this. Okay, we have done level order successor. Suppose we have a node like this: 1, 2, 3, 4, 5, and it does not have anything. Let us say it has 6 over here. So the level order successor of the node 2 will be 3, 3 will be 4, 4 will be 5, like that. Alright. So if the level order successor of 6 won't be anything because it does not have anything after this. Okay. So what we can do, we will make the queue. This is the queue. We will insert 1. Is it equals to the key? Key may be equals to 3 first. Let us say, okay. So is it equals to the key? It will say no, it is not. So it will pop it and insert its children over here. 2 and 3. It will come to 1 second. It will ask 2. Then, are you equal to 3? It will say no, I'm not. So it will again pop its children 4 and 5 into the queue. say, are you equals to 3? It will say, yes, I am equals to 3. So then it will pop 3, and because it does not have any children, it is not inserting anything there. If it had any children, suppose if it had 11 here, then it would also enter 11 over here. Because let us suppose you don't have this subtree over here. You don't have, suppose, this subtree over here. Then the successor of 3 would be 11. The level order successor of 3 would be 11 only. So that is why before inferring your answer, we have once you have found the node where the value is matching to the key value, then also you have to pop it first, then you will check for the next answer. Okay, so you have popped 3 and you have inserted this thing, okay, 11 over here, and now this value will be the successor of the node 3 over here. If 11 was not there, if 11 was there only, then also 4 would be the successor of that. Let us see for 6 what would happen. For 6, it will come to 4, it will say, are you equals to 6? Would say, no, I am not equals to 6. Then it will pop 6, it will insert 6 over here, okay. It will say that, are you and pop 4, it will say, it will ask 5, are you equals to 6? It will say, no, I am not equals to 6. Then it will pop 5. It will come to 11, it will say, are you equals to 6? 11 will say, no, I am not equals to 6. Then it will pop because it does not have any children like here. Then it will come to 6 again. It will ask it that, are you equals to 6? It will say, yes, I am equals to 6. Okay. Then if you have any children, then pop it. Then because we want to find your successor, we'll say, okay, I don't have any children, but I don't have any children because I don't have any children, but then too I will pop myself. So it will pop it. So ultimately the queue will become empty in this case. So if the queue becomes empty, then we have to infer that the 6 does not have any successor. When we do level order traversal or BFS traversal, breadth first search traversal, for 3 we know that 3 has a successor which is 4. So this simple question was asked by Google as per Kunal Kushwaha. So we will do that. So if the root is null, if self.root is none, then we won't return anything. We will return none. Okay. If it is not none, then we will have to have a queue. The queue is initially empty. So after that, what do we need to do? While queue is not empty, you have to check if key is equals to initially queue won't be empty, it will consist self.root. We'll see if key is equals to we will pop the node over here. Node will be equals to queuv dot pop the first index, the first item. Okay, and after popping we will check if node and then we will also enter the left and right value from the node into the queue. So let us do that first. Left is not none, then QUE dot append node dot left. Okay, if node dot right is not none, then we will append QUE dot append node dot right. Alright, then these things are done. Then we will ask the node that if RU equals to the key value over here. If it is equals to the key value, if node dot value equals to key, then what do we need to do? If node dot value is equals to key, then we have to print. We have to say that, yeah, we have found it. We have found it. Break the while loop. Alright. Otherwise, continue until the queue is empty. Okay, and then we will return, we will say if queue is not empty, then we will return queue dot first index, queue's first index. Else we know that it does not have any successor, so we will return none. So let us see for our case whether it gives us a proper answer or not. So 1 2 3 4 5 6 7. Let us see. Print binary dot level order successor, where we have to give a key. Let me give key as 7. It should give me none value because 7 does not have any successor. Okay, it is giving me none. The successor of, let me see, the successor of 6 should be 1. So let us see whether it gives me 1 or not. So successor of 6 should be equals to 1. Is it giving me 1? It's giving me a node value. So we are not returning. We don't want to return. Where is it? Yeah, we don't. Yeah, here. Don't want to return the node. I want to return the value here. Okay, that is why I will say value. Now it should show me the value. Yeah, it is showing me 1. So it is working perfectly fine. So no need to check Kunal's code. He has also.
I will just stop the program.
He has also done the same.
In the end, I'll just remove whatever is next in my queue. Done. That's it. And you're also aware of the time answer and y2. So check it out. Bref first search will be used. But how do we print it in zigzag order? Let's see.
Zigzag order. Let us try that first. Then we will see Kunal's explanation. Similar question. Zigzag binary tree. Here I guess I found it. Yeah. Zigzag order traverses was asked by all the big companies: Amazon, Microsoft, Facebook, Bloomberg, Google, Apple, LinkedIn, Oracle, Adobe. Like that, these companies have asked the question. So given the root of a binary tree, return the zigzag level order traversal of its known values from left to right, then right to left for the level order and alternate between. Alright, so let us see what do we get here. The root equals to 3, 9, 20, null, 15. This binary tree is given to us. Then we have to, what do we need to do? 3 and 20 and 9, 15 and 7. Okay, I got it. It is easy, it is not that hard. So first 3 we have to do, okay. Then in the second level we have to go like this, then this, then this, then this. Okay, won't be a problem. It will be quite easy as far as I can see it from here. Zigzag traversal. Okay, so let us take the same that it has given to us. Okay, 15 and 7. So we have to alternately we have to insert it. Alternately we have to insert the children values. Okay, not a problem. So for the odd values we are going, so if we say this is level 1, 2 and 3, so we are going like this. So for odd values we are going from left to right, for even values we are going from right to left. Okay, so one thing noted for odd values, for, let me switch it, yeah, for odd values we are going from left to right. For even values we are going from right to left. Okay, but again no problem, we are going level by level, so it is a simple BFS question. Okay, so let us say we have a queue. Initially it has the root node. Okay, so the current situation we have odd. Okay, so the children of the odd are from left. Okay, so when we are at level odd, current level we have odd. In odd, the children of odd are inserted from right to left. Okay, so we have to change this. So when it is odd, we are inserting it from right to left. So first we will insert 20, then we will insert 9. Okay, then then we have a problem now. Okay, the problem we are facing that we have to get the value. We have to get the value of 9 before 20 for the values of 20. How can we get that value? How can we get that? We can just reverse it as well if we want. Shall we try it? Shall we cheat the lead code? We can do that in emergency situations, but let us learn. I want to learn. How can I overcome that? So 20 is here. 20 is here. So 20 is here, but I want the children of 9. Then what should I do? Let's say 9 has 2 children. Okay, 9 has 2 children. Let's say 69 and 99. Alright, then how can we get the children of 9? And let us say in a big tray, how can we get those children like that, right? How can we get that? We'll say we can just reverse it. Will it run on lead code? Shall we try? Let us try to cheat lead code. So if root is none, then return an empty list. Okay, if root is none, return an empty list. Otherwise, we'll have an answer which is initial and empty list. We will have a queue which initially has root dot, which will initially has root as its node, and while queue is not empty, we will traverse it. So node will be equals to queuv dot pop the first item, and we will insert I have to do one more step over here. So the number of iterations will be length of the queue as of now. Okay, so the level should be equals to an empty node as of now. So the for loop should run for I in range n. We have to go level, we have to go node equals to queue dot pop the values. Okay, and then we have to check if node dot left. If not, then insert the value into the queue. Queue dot append node dot left. If node dot right is also not done, then insert the value as well into the queue. Node.write. Then is a list of integers. So after that, in the level section, we will insert level dot append node dot val or value. Yeah, val over here. So after this for loop got finished, we'll reverse the level dot reverse. So it will take O of n log n time. Yeah, we'll take O of n log n time. Then we will append it inside it. Append the level. Append it to the answer, and then we will return it. Let us see whether it returns or not. Yeah, it's running. Okay. What's the problem? It is reversing at every level. Okay. Now what we need to do is whenever the level initially, let's say level equals to 1. Okay, so level is odd equals to true. When level is odd, it is going from left to right. When level is even, then we are going from right to left. Okay, but when the level is when do we need to reverse it? Okay, level is odd is true. When the level is even, then we need to reverse it. So level equals to 1 initially. So here, after the iteration, the first level has the node. Okay, then we will increase the level. Level plus equals to 1, and then we will only reverse it if level mod to 0, then only we will reverse it. Level dot reverse. Let us see if it runs or not. Runtime error. Okay, it got initialized. Current level count. Let us see. Copy it, paste it. Let us run now. Yeah, it's working. I guess it in some really big test case. No, it is running. What the hell? I thought in a really big test case it might have given running out of time limit exceeded, but it is working. If it is working, then why should we bother? But let us see the more efficient approach as well here.
Let's say you're given a
Hey guys. I guess I have to go for a little break, so I will go. See you.